How to weld T and open corner joints in the overhead position on aluminum plate using the gas metal arc welding process, commonly referred to as MIG welding. Prior to doing this operation, you must be able to weld the open corner joint in the horizontal position.
This training tape you are watching will demonstrate how to weld two different types of joints in the overhead position.
It is important to show where one of these joints might present itself in a field environment. A hole is punched in the side of my Bradley. I need to move out with my unit in the morning. Can you help me?
This particular area of damage on this M3 is made out of aluminum 7039 alloy. The best thing to do in this situation is to weld a patch over the hole with compatible aluminum plate. This patch will allow us to weld open corners in a vertical, horizontal, and overhead position. As with everything, safety is first. You must remove watches, ID tags, and all jewelry.
The wedding band may be taped to your finger to prevent electrical shock. Ensure that you have proper ventilation. Here's the personal safety equipment needed to perform MIG welding operations. A welding cap. Hearing protection. Not only will this protect against noise, but also in stopping flying molten metal from entering the ear canal. When using this type of protection, ensure proper fit. A welding apron. A welding jacket. Safety glasses. Welding helmet. Inspect the helmet to make sure it has no cracks or holes and that it has a number 11 shaded lens. Caution. Ultraviolet radiation, UVR, can cause burns to the skin and eyes, which have both short and long-term effects. Short-term effects result from exposure to excessive amounts of UVR over a short period of time. Long-term effects happen slowly and painlessly, yet they both can impair vision and in some cases cause a partial loss of vision by causing eye cataracts. Welding gloves. And Training Circular 9-237, Operator's Circular Welding Theory and Application.
When you are ready for safe welding, then we can begin setup for MIG welding. This welding machine is capable of performing stick, TIG, and MIG welding operations with the use of a portable wire feeder box.
Caution. It is very important your machine setup is correct to prevent damage to the equipment and personnel.
This is the current range selector switch. This switch provides overlapping ranges from 2 to 375 amps. As you can see, it has 5 selections ranging from minimum, low, medium, high, to finally max. For this setup, we want to select max, allowing for enough heat for proper welding.
Caution. Do not change the current range selector switch while welding. Doing so can cause arcing between the contacts, which may result in immediate failure or, most certainly, shortened switch life.
Set the fine adjustment by turning the current control dial to 3 1/2 for your starting reference point. If you need to increase the heat, turn the dial to a higher number. To decrease the heat, turn the dial to a lower number. Next is the power switch. It has two settings, on and off. When the power is on, the red light comes on. For now, we will leave the power off until we have made all the correct settings. Here we have the electrode polarity switch. This gives the operator a choice of AC, DC negative, and DC positive, whichever is required for a particular application. In this case, we need direct current positive.
Caution! Do not switch under load. Just as with the current range selector, switching while welding can cause damage to the machine. Ensure that you set the handle only on the arrows for the same reasons.
All right, now let's move over here to the left and take a brief look at the afterflow timer. This dial deals specifically with TIG welding. We are setting up for MIG welding. This control dial has nothing to do with what we are doing, so we'll just ignore it and bypass it. Now we have the remote control receptacle. This allows for optional features such as a foot amp control. This is another item used exclusively for TIG welding. Before we ignore and bypass this one, there is one note worth mentioning related to it: the current control switch, which is the switch over here to the right. This is the current control switch. Flicking the switch down allows the current to be controlled by the remote control device, which would be connected to the remote control receptacle. Moving the switch to the up position would allow the current to be controlled by the machine itself. The current control switch is now set at TIG 300. This is the welding mode switch. When welding with the TIG process, the switch is put in the inner gas welding position. Set the switch in the stick welding position for stick or MIG welding. We will leave the switch in the down position because we are setting up for a MIG operation. Moving on, we come to the soft start switch, which provides a low weld starting current to prevent burn through of light gauge metals when using the TIG welding process. As you probably have already deduced, this switch has nothing to do with MIG welding, so we will place it in the off position. Next, we have the spark switch. This switch has three settings: start only, off, and on. We will leave this in the off position since it deals only with TIG welding. What we have here is a 15 amp, 115 volt slow blow fuse. And finally, two 115 volt electrical outlets. Now let's go back over our control panel setup and see what we've done.
The current range selector switch is set at the maximum range. The power switch is in the off position. The electrode polarity switch is set on DC positive. The welding mode switch is on the stick welding mode. The soft start switch is in the off position. And the spark switch is set in the off position. The current control dial is positioned at 3 1/2. The current control switch is set at TIG 300.
Okay, let's take this opportunity for a little quiz to measure what you have learned about this control panel setup. You will be asked 3 questions, one at a time, with a 20-second pause at the end of each question asked, to see if you can come up with the correct answer in your own mind. Perhaps you may want to review this tape if you find difficulty with any of the 3 questions asked.
What is wrong with the setup of this control panel that won't allow the welder to strike an arc? If you identified the welding mode switch being set in the inert gas welding setting, you're absolutely right. It should be in the stick welding mode. Not counting the power switch being off, how many setup mistakes do you see on this control panel? 1, 2, 3, or even 4? The correct answer is 4. Let's take a look at them. First, the current range selector switch should be at the maximum range. Second, the electrode polarity switch should be set on DC positive. Third, the current control dial should be set on 3 1/2. Fourth, the current control switch should be in the TIG 300 position. Is this machine set up correctly? Yes or no? If you answered yes, you're absolutely right. The setup on this control panel is correct.
Now let's take a look at this portable wire feeder box.
This is the idle roll pressure setting. The manufactured groove on this wheel is used as an indexing reference point. Turn the wheel counterclockwise until it stops. Now, look at the notched groove in the wheel and turn 2 1/2 turns clockwise and stop. Lock the idle roll into position.
This is a good setting to start with. When you turn the wheel to the right, you're increasing the pressure on the wire. And when you turn the wheel to the left, you're decreasing the pressure on the wire. Remember, too much pressure or even not enough pressure on the wire will cause burn back. You only want enough pressure on the wire to pull it through.
Here we have the wire feed mode. The wire feed mode must be flipped to the constant current or CC position. Keep the door closed during welding operations. Ensure your dial range toggle switch is in the high position. The wire speed should be set at 650 and adjust as needed. This is the polarity switch. It must be in the positive position because you must match the electrode polarity on the welding machine as it too is set on positive. This is done as shown here. This wire leads to the wire feeder clip. The wire feeder clip must be grounded in order to establish an arc. Next, turn the argon cylinder valve counterclockwise all the way, allowing the argon to flow to the regulator. Turn the wire speed to the lowest setting to conserve wire. Turn on the welding machine, squeeze and hold the trigger on the MIG gun. Caution, the wire is electrically hot and will arc. Next, set the CFH, or cubic feet per hour, to 40 on the argon flow meter. Graduations are read from the top of the ball. Release the trigger and cut off the excess wire so that only a ½ inch is left protruding. You must turn the wire speed back to 650. Otherwise, you will experience burnback. To weld a T-joint in the overhead position, you must first clean the joint. Adjust the jig to position the T-joint in the overhead position. Using the forehand technique, hold the nozzle at 90 degrees to the axis of the joint. From this position, tilt your torch 5 to 10 degrees away from the direction of travel. The forehand technique is preferred for aluminum as it provides a cleaning action ahead of the puddle and provides better shielding of the molten puddle. Wire brush your bead. The bead should look like this, with the bead toes fused into the base metal. When welding the second bead, you should aim your wire at the bottom toe of the first bead. From the perpendicular position, ensure that all the string beads have a 5 to 10 degree tilt of the torch away from the direction of travel. Notice how the torch is no longer pointed directly at the axis of the joint, as it was with the first bead. Ensure that the second bead is laid directly over the bottom toe of the first bead. Wire brush your bead. Bring down the temperature of the base metal to prevent it from overheating. When welding string fillets, it is important to ensure that the toes of each bead blend in gradually and smoothly into the surrounding beads and/or base metal. Now, this third bead will be laid across the top toe of the first bead, as shown here. Notice that the angle of the wire is different than that of the first and second bead. The wire is now pointed above the axis. Ensure that the bottom toe of this puddle fuses into the second bead and the top fuses into the upper base metal. Remember, what you see molten is what you get solidified. The first bead has been covered up by second and third interlocking beads. Now that the 3 beads have been laid, it is time to clean the nozzle. Caution, the nozzle must be cooled to prevent burning of your hands. Cleaning is important because the spatter inside the nozzle restricts and reduces a good even flow, which can result in a contaminated weld due to poor shielding. The use of anti-spatter compound is a must when welding in the overhead position. A thin coat on the inside wall of the nozzle will aid in the repelling of the spatter, preventing it from sticking to the wall and thus keeping the gas flow steady and even. This is what it should look like with 4 beads. This is what your joint should look like with 5 beads. The weld area must be free of spatter, scale, and pitting. This is a T-joint with a finished fillet weld laid in. The edge of the weld must be free of undercut or burning away of the base metal at the toes of the weld. In a T-joint, the fillet should be concave. The open corner joint in the overhead position will be the next weld. The angles used for this joint are the same as those used for the T-joint. The first bead should be laid directly in the corner of the joint, with its toes fusing evenly into the base metal. This is the first of 6 beads. Notice the face of this bead is convex and uniform in appearance. The second bead is to be laid directly over the bottom toe of the first bead. The third bead will be laid across the top toe of the first bead. The second and third beads, as shown here, should only be wide enough to cover up the first bead, without letting them touch the top corners of the joint. Don't let the toe of the fourth bead wash over the corner more than 1/16 of an inch. This is what the joint should look like with the fifth bead. Here is the completed fillet weld in the open corner joint. It should present a convex appearance. Notice how the string beads interlock with one another and the corners of the joint.
I believe it's time to take this patch and go back to the field and do some repair work. As soon as I finish my setup, I'll start welding the open corners. When you do your future patch operation, don't forget to paint it when you're done. Have a good day. Fire it up.
You've just watched a training tape on welding a fillet in a T and open corner joint. If you have any questions, review this tape.